Good day, everyone. For the next topic, after the discussion of the Napier's rule, in which we derived formulas, equation from the circle, and then also deriving for the formula of an unknown part of a right spherical triangle. So now, as what I mentioned last time, that the next would be solving of a right spherical triangle. This is only a continuation of the derivation using the Napier's rule. First of all, you really need to know how to derive formula. So remember that we do have two rules in the Napier's rule, in which the first rule is if we do have the middle part, and then we do have two parts that are adjacent to it. So therefore, what we're gonna have is the sine of the middle part equals to the product of the tangent of the adjacent parts. Another rule, if you can still remember, so if we have the middle part and then there are two parts which are opposite it, therefore our formula would be the sine of the middle part equals to the product of the cosine of the two opposite parts. Okay, so you really need to learn how to derive. And then for this topic in the solution of a right spherical triangle, so what we're gonna have now is well, the given parts with measurements. So it means that if we will be asked for a particular part of the triangle, of a right spherical triangle, so we need to determine the measurement of the said unknown part. Okay, so this is example number one. Solve the right spherical triangle ABC with angle C that measures 90 degrees. Remember that a right spherical triangle, as I mentioned last time, it has an angle C that is always 90 degrees. Okay, that is the clue. And then also, so considering this problem, it is said that side A measures 75 degrees and 40 minutes, and then side B is 61 degrees and 30 minutes. So remember that in the discussion about spherical trigonometry, if we do have a spherical triangle, so the angles as well as the sides of the said triangle are actually in degree measure. Okay, so all are in degree measure because the side of the sides of a spherical triangle is not, it doesn't look like, or those sides do not look like line segment like an ordinary triangle. But then with the spherical triangle, the sides are actually arcs, which are parts of the great circle. Okay, so in solving this, so let us switch to the black screen. So again, we do have the given. So let us write the given first. So the given, we do have C of 90 degrees. So this means, this is a clue that our triangle is right spherical triangle. Okay. Then we do have two other given parts. So we have A that measures 75 degrees and 40 minutes. And then 61 degrees and 30 minutes. Okay, so let us solve for the unknown parts of the said right spherical triangle. Because remember, it is said in the problem, solve. Okay, solve. So when we say solve, it means that we are going to determine the measurement of the other parts. So what are the other parts? So if we do have here angle C, so it means we need to determine angle A, angle B, and then with A and B as the side, so we need to determine side C. Okay? I'll just write here side so it wouldn't be mistaken as a big C. Okay, so remember in solving a right spherical triangle, so we always need to start with a circle, just like our discussion last time. So the circle, remember, you do need to um divide it into 5 parts. Okay, and then remember you have to put inside the circle the 5 parts of the spherical triangle. So we do have side A, which should be beside side B. Remember that. And then opposite sides A and B is actually the complement of side C. And then here we do have the complement of angle A. Then here we do have the complement of angle B. So let us just double check our circle. So we do have A, B, A, then we have here the B, then opposite A and B is the complement of side C. Okay, same way of drawing the circle with 5 parts. Now, so if you remember the way we derived before, okay, so the given is side A. Also, we do have side B. Okay, so with the two given parts, you try to solve any of the unknowns. So if you would like angle A first, angle B first, or side C first, it will depend on you which one would you like. So remember that when you make use of the Napier's rule, so remember that in the Napier's rule, so in using it, okay, there should be 3 parts of a spherical triangle. So a right spherical triangle. When we say 3 parts, so this means that two are given, okay? Two are given and then one is unknown. So since in our problem, we do have the given side A and side B, so it means that any of the three unknowns can be our what? Our third part in solving. By the way, class, we do not use this angle C in our circle because angle C is not here. So what we're gonna use are the other two, okay, the A and the B. So angle C is only a clue that the spherical triangle is right. Okay, now, so since we have sides A and side B, so let's just say that you want to solve for the other side. So let us solve for side C. So remember, if you would like to solve for side C, okay, so you encircle it so that you can think of what Napier's rule you are going to use. Okay, so I will erase this portion. So by looking at the circle, so possible you already have the idea of what, well, which of the two Napier's rule you are going to use. So let us label first, okay? So with this, so we can see that A is beside B. So these two are adjacent with each other. So looking at side C, okay, side C is opposite A. It is also opposite B. So we can say that this one is our middle part, okay? And then these two are opposites. So we can say that what we can use is what? The Napier's rule number 2. Okay? Napier's rule number 2. In Napier's rule number 2, so remember, so we do have the sign of the middle part. Our middle part is the complement of C equals to the product of the cosines of the two opposite parts. So cosine of A, so well, you can use parentheses if you only have A, B, but then use parentheses if you do have the CO. Okay, so cosine of A times the cosine of B. So you can omit the period here, the dot. You can omit it. And then, so remember that this is the equation from the circle. So this is the equation from the circle. So equation from the circle. Okay. Next, so let us have our final equation. For our final equation, so remember that you need to remove the CO. Okay? So in removing the CO, remember um, for the cofunctions, so just remember for the cofunctions, so if you do have sine, so you're going to replace it with cosine and vice versa. And then if you do have tangent, replace it with cotangent and then vice versa. So for this final equation, so we can see on the left side that we do have the CO. So to remove this CO, so remove CO, okay. So we need to replace sine with cosine because sine, the cofunction of it is cosine. So cosine, and then copy the part of the spherical triangle, so that is C, equals. Then on the right side, we do not have any CO here, so we're just going to copy it. Cosine of A times the cosine of B. Next, let us derive the formula. Okay, derived formula for the unknown. So what we are doing right now is somehow the same as our last topic. This is actually derivation, so we're not yet in the substitution. So in deriving the formula, so since what we need is so side C, our side C is here. So even if, so just remember, even if in the spherical triangle, in the right spherical triangle, the part is side, okay? Remember that the side is in a form of arc because it is part of the great circle. And the unit of it is also in degree. Okay, it is somehow the same as an angle. So you would notice that in using the Napier's rule, we do have here cosine of a side because the side is also in degree measure. It is like an angle. So it means that we can also use here the inverse trigonometric function. Okay, so as what you can see, since what we need is side C, so we're just gonna copy the side C equals, and then we need to move cosine to the other side. So in moving cosine to the other side, so it will become inverse of cosine or arc cosine. And then you're just gonna copy the right side. Okay, that's it. And then next, we can already now substitute. So let us substitute in order for us to solve the triangle, okay? One of the parts of the triangle. So our cosine of the cosine of our A is 75 degrees and 40 minutes times cosine of 61 degrees and 30 minutes. Okay? So input it in your calcu. So in inputting in your calculator, remember your calculator should be in degree mode. So that is our cosine of 75. So we do have here degree in minutes. So you press the degree, minute, and second key. Input 40. Okay, input 40. Degree, minute, and second key again. Then you close parenthesis it. By the way, please use enough number of open and close parentheses so that your angle won't be multiplied to the cosine. Okay. Then times. So cosine of 61 degrees DMS, 30 minutes DMS. Then you can close it already. Okay. So in your calculator, because we do have here two cosines, so you input first. Again, input first our cosine. Be sure that your calculator is in degree mode. So the R cosine already has an open parenthesis. Okay, when you click on it. So what you're gonna do, you press or you click on open parenthesis again. Okay, so we have cosine, R cosine. Then automatic, there's an open parenthesis. You click on open parenthesis again. Then input 75 degrees. So DMS, 40 minutes, DMS, close close parenthesis again. Then multiply it, open parenthesis, cosine. So the cosine has open parenthesis, so automatically. Then input 61 degrees, DMS, 30 minutes, DMS. Then you close it, another close parenthesis, and then another close parenthesis. So press equal sign. The answer in the calculator is 80 degrees and 22 minutes. In DMS, so it is 80. I'll just write it. So C equals to 83 degrees, 12 minutes, and 58 seconds. 12 minutes and 58 seconds. So please practice in your calculator how to input this. Okay. So this is the measure of side C. Okay. Again, side C is in degree. Okay, because it is like an angle, because the triangle is a right spherical triangle. Okay, just remember in your calculator, please use proper parentheses. So you really need to practice how to input it in your calculator. If your calculator well gives a different answer, please double check your parentheses. Possible there's a missing pair of open and close. Okay, next. So I will be clearing the writings. So we're gonna use the same circle, but impossible. Well, let's see if we can make use of the same Napier's rule. But then of course it will depend on the location of the parts. Just remember to enclose in a box your final answer whenever you do solve. Okay. So we already have side C. Okay. Again, in solving the right spherical triangle, you need to make use of the given. So the given are A and B. So let us solve for the other one. So this time, let us solve for angle A. Okay. So in solving for angle A, you take a look at these three parts. Angle A, side B, side A. So in using the neighbor's rule, okay, in using the neighbor's rule, you need to determine first which one is the middle. So the middle is, of course, side B. It is very obvious. And then the other two, which are beside it, so they are adjacent parts. Okay, now, so with the middle and then adjacent part, so it means that what we're going to use is Napier's rule number one. So in Napier's rule number one, so it is said that the sign of the middle part, so the middle part is B, so we're not going to use parentheses anymore because it doesn't have the CO. So we can just write sign of the middle part B, okay, equals to the product of the tangent of the adjacent part. So tangent of the adjacent parts. So CO, that is the complement of angle A, then times the tangent of side A. Remember with the product, with the multiplication, you can use dot or none. Okay, none, because it is already understood that the operation here is multiplication. Okay, now let us have the final equation. In the final equation, so we need to get rid of the CO. And in getting rid of it, so we need to what? We need to apply the cofunction. Okay? So let us copy first the left side. So we have sine of B because it doesn't have CO, so we're just going to copy it. And then tangent of the complement of A, so we have CO here. So to remove this, we need to replace tangent as what? Replace it with cotangent. And then of the part, angle A, then copy tangent of A. Okay? Next. So I'll just make it, I'll just rewrite this one. So derived formula. Derived formula for the unknown. Okay. So in deriving the formula for the unknown, so the first thing that you need to do here, well, you have to write cotangent in terms of tangent by making use of identity. Okay, so remember that cotangent theta equals to 1 over tangent theta. So it means that we can write sine B equals, so cotangent theta is 1, or cotangent A is 1 over tangent of angle A times 2 tangent of side A. And then, so simplifying this, we do have tangent of side A equals to tangent of angle A. Okay, next. So what we need is the big A. So we need the big A because it is what we are solving. You look at our unknown. This is what we need. So by applying the cross multiplication, so you can interchange the two. So simply interchange the numerator or the term on the left side with the denominator on the right side. Okay, we can interchange this two. So what we're gonna have is tangent of angle A equals to tangent of side A over sine of side B. Okay. And then since again what we need is angle A only. So we can write tangent on the right side. So if we're gonna write tangent on the right side, so that will be A equals to arc tangent, and then you copy tangent A over tangent of, that is sine of B rather. I'll just rewrite it. So that is tangent of side A over sine of angle B. Okay, so this is already the derived formula for the unknown. And then, by the way, so we are given the measurements of A and B. So we need to substitute it for us to have the measurement of angle A. Okay. So let us substitute. By the way, I'll just erase this portion here. I'll just erase this portion. So that is, I'll just rewrite it. So tangent of angle A equals to tangent of side A over sine of side B. Then again, we are going to move tangent to the other side because what we need is angle A only. So that is A equals to arc tangent. So we're gonna apply the inverse trigonometric tangent of side A over sine of side B. Okay, now we can already substitute. So this is the derived formula. So this is the derived formula for the unknown. And this is the one that you are going to use for the substitution. So we have A equals to arc tangent. Then you just substitute. So tangent of side A, that is 75 degrees, 40 minutes, divided by sine of side B, 61 degrees, 30 minutes. So you input it in your calcu. So arc tangent, 70, arc tangent of tangent 75 degrees. So let us input it. So arc tangent of 75 degrees, 40 minutes, close parenthesis, divided by sine of 61 degrees, 30 minutes, close parenthesis. So the answer in the calcu is 77.34 degrees in degree, minute, and second. So that is 77 degrees, 77 degrees, 20 minutes, and 39 seconds. Okay, then just enclose in a box your answer. Okay, that's it. So what you need again here is know how to derive the formula, because if you can derive the formula from the circle, okay, the Napier's rule, then coming up with the final equation, considering the cofunction to get rid or to remove the CO, then derive formula. So what you only need is to substitute at the end. so that you can have the measurement of the unknown part. Okay, so we already have angle A. So the next one that we are going to solve now is angle B. Okay, so we're just gonna clear this, right things here. If you want to create different circles for different parts, you can. Okay, you can. So let us remove this. Okay, so what we need now is angle B. So again, we do have the given sides A and B. So here is angle B. Okay, now look at the circle again. Identify which one is the middle part. So the middle part here with a big a and small b. So of course, we do have small a as the middle. And then looking at the two parts here, they are beside. So since they are beside, we can say that the two are adjacent parts. And with the Napier's rule, so considering that the sides, the two parts are beside the middle, so they are adjacent, therefore what we're going to use is Napier's rule number 1. So again, Napier's rule number 1, the sine of the middle part, so the middle part is side A, equals to the product of the tangent of the two adjacent parts. So tangent of the complement of angle B times tangent of side B. Again, for this, so since the right side is product, so it is multiplication. So you can use a dot or none. So you can just write it as simply tangent of the complement of angle B tangent of B because it is already understood that it is multiplication. Next. So for the final equation, so we need to remove the CO. So CO here. So on the left, sine A doesn't have a CO, so we're just gonna copy it. On the right side, so we have the tangent of the complement of B. So complement, so remove the CO. Remember the tangent can be replaced with cotangent. Okay. Then copy the side or the part. Okay, copy the angle, the part of the spherical triangle. So that is angle B. And then copy this tangent B. So we already have our final equation. Next, we need to derive the formula. So go as what you can see, so we do still have here cotangent. So what we need here, so we have to use identity again. So that cotangent of theta equals to 1 over tangent of theta. So we're gonna write it left side. So sine of side A equals to 1 over tangent of theta. By the way, our theta is angle B in the problem. So angle B times tangent of B. So as what you can notice, this is also the same solution as what we did with um with the previous one. Okay, they are somehow alike. Okay, now, so we need to multiply the right side. So we have sine A equals to 1 times tangent of side B is 1 tangent B over tangent angle B. Okay, next. So I will be removing this for removing that portion. Okay, this one so that we can write the other parts of the solution. Okay. So since what we need is angle B. Okay, so we need to write it on one side, okay, alone. So as what you can see, so by means of the cross multiplication, simply we can just what? We can just interchange the two. So the sine A can be, well, we can write it as the denominator of the right side, and then tangent angle B, so we can write it on the left side. So we can switch the two. That is in cross multiplication. So if you are not familiar with this way of cross multiplying, you can do the conventional, the step-by-step cross multiplication, but then you're still gonna arrive at the same well the same equation here. Okay, so if you're going to switch the two, okay, under the cross multiplication, so the left side will be tangent of angle B. Tangent of angle B is the denominator of the right. So this time we're going to write it on the left. And then numerator of the right, so the same, tangent of side B. And then its denominator now, after cross multiplication, will be sine of side A. Okay, next. So since we need to derive the formula, so we need to write B alone on one side, angle B. So we need to transfer tangent to the other side. Okay, so it will become B equals to arc tangent, and then copy the right side, tangent of side B over sine of side A. This is our derived formula. Okay, and then now, since we already have the measurements of side A and B, so we can already solve for the measurement of angle B. So just by substituting, so tangent, so our B here is 61 degrees, 30 minutes over sine of side A, that is 75 degrees and 40 minutes. Okay, then just use your calculator. So input it. So in your calcu again, so be sure that you are in degree mode. So arctangent of tangent 61 degrees. So use the DMS divided by that is sine of 75 degrees, 40 minutes, close parenthesis. So the answer in the calculator is that is 62.25 degrees. So convert it to DMS. So the answer is 65 degrees. Oh, wait. So the answer is 62 degrees, 15 minutes, and 11 seconds. So this is the measure of angle B. So again, angle B is 62 degrees, 15 minutes, and 11 seconds. Okay? So that is for the right spherical triangle, the first example. So next, let us go back to the slide. So we have another example here. So again, solve the right spherical triangle. When we say solve, so we need to determine the measurement of the other parts. And again, so it is a right spherical triangle A, B, and C, wherein angle C is 90 degrees. So when one of the angles is 90 degrees, therefore the spherical triangle is right. And then, so when angle C is 90 degrees, okay, angle C. Um, with other given parts, which are angle A that measures 44 degrees, 10 minutes, and side A, which is 35 degrees and 20 minutes. So we're just gonna do the same. We're just gonna do the same here. Okay, so let us switch to the black screen. So for the given, so remember the given, so angle C measures 90 degrees. So this means we do have right. So it means we have right spherical triangle. Okay, next. We do have another given. So angle A that measures 44 degrees, 10 minutes. And then the other one, side A that measures 35 degrees and 20 minutes. So what do we need to solve here? So we do have the angle C and A. So it means we need to solve for angle B. We do have side A. So what we need are side B and then side C. So this is side C. So the same, we're gonna draw a circle. Okay, then you have to divide it into 5 parts. Then create your own circle. So be sure that sides A and B are beside each other. And then opposite it is the complement of side C. Then we can write here the complement of angle B. And then here the complement of A. So double check your circle before you proceed with the computation. So we do have BABA. So the BABA, the letters are written alternately. Okay. Then C, the complement of C, it is opposite sides A and B. So therefore our circle is correct. Okay, now, remember what we need are the Napier's rule. Which Napier's rule are we going to use? What number? So that we can come up with the equation from the circle. And then we also need the final formula and also derived formula. Derived formula for the unknown. This is for the unknown. Okay. So with the Napier's rule, so before we can determine which rule to use, so let us take a look at the two given parts here other than the angle C. Because remember, angle C is not in the circle. So we're gonna make use of the two other given parts. We do have the big A and then also the small a. Okay. So in using the Napier's rule, so there should be 3 parts again. So 3 parts, 2 parts given, 1 part is unknown. So we already have here 2 parts. So you can try to choose which one would you like to solve first. If you would like to solve for angle B first, or side B, or angle C, it is up to you. Okay, so let's just say we want to solve for example, let us solve for side B. So solving for side B. Okay. After you locate the side B in your circle, so again, you need to determine which one is the middle part. So we have A, B, big A. So the middle part is B, the small b. And then the two A's here are adjacent. They are beside side B. Okay, so since the two parts are adjacent or beside side B, we can say that we can use Napier's rule number 1. Then let us just write the equation from the circle. So sine of the middle part is B. Side B equals to the product of the tangent of the adjacent parts. That is our Napier's rule number 1. So tangent of side A times tangent of the complement of angle A. So this is our equation from the circle. Next, for the final equation, remember we need to consider the use of the cofunctions. This is in order for us to remove the CO. So again, if we do have sine, we're going to replace it with cosine and then vice versa. If we do have tangent, we're going to replace it with cotangent and then vice versa. That is for the cofunction identities. So here, as what you can see in our equation from the circle, so the left side is sine B, so it doesn't have the CO. Then on the right side, we have tangent of A. It doesn't have the CO also. So we're just going to copy it. And then what we're going to have, tangent of the complement of A. So we have CO. So to remove this, we need to replace tangent with cotangent of the of angle A. That's it. So just copy the part. For the derived formula, okay, so as what you can see, we do have here cotangent. So the cotangent, this one, so we need to use identity. Okay. So let us just rewrite the left side. So that is sine B equals to tangent of A. So this is on the right side. And then cotangent of angle A, it will become 1 over tangent of angle A. Then the same, you're just going to multiply once you see this format. So tangent A times 1. So that is tangent of side A divided by tangent of angle A. By the way, class, if you see tangent A over tangent A, you cannot cancel this because the first A, the small one, is side. The second A is angle. They are different. Okay. Next, what do we need again in this problem? So what we need is side B. So this is side B. So we can simply what? We can simply move sine to the other side. Okay, so we have here B equals to arc sine, then tangent of side A over tangent of angle A. Then we can already substitute. Actually, this is the derived formula. This is the derived formula. So we can already substitute. So B equals to arc sine of tangent of 35 degrees because small a is 35 degrees, 20 minutes. And then tangent of big A is 44 degrees, 10 minutes. So double check. Tangent 35 degrees, 20 minutes. Tangent of 44 degrees, 10 minutes. So what will be the measure of our side B here? Okay. So input it in your calcu. So again, be sure it is in degree mode. So arc sine, tangent of 35 degrees, 20 minutes, divided by tangent of 44 degrees and 10 minutes. Then you use close parentheses. The answer in the calculator is 46 degrees, 52 minutes. So let us just write it. 46 degrees, 52 minutes, then 23 seconds. 23 seconds. Then you just enclose it in a box. Okay. So B equals 46 degrees, 52 minutes, 23 seconds. So that is the measure of side B. Okay. So after that, you can choose again between angle B or side C. Which one would you like to solve next? So let us try to solve another. So let us just clear this, remove this. So again, if you want to use a different circle, you can. Okay. I'll just clear this. So again, what is important here is you know how to determine or get the equation from the circle using the Napier's rule. Then come up with a derived formula for the unknown. Okay, so let's just say that we want to solve for side C. Okay, side C. Side C. Here's side C. So as what you can see, so we already have here three parts, two parts given, one part is unknown. So in using the Napier's rule, so we need to determine which one is the middle part. So the middle part here is what? So angle A and side C are beside each other. Opposite them is side A. So this is our middle. And then automatic, the other two are opposite. So if we do have opposite parts, so it means we can use Napier's rule number 2. So in Napier's rule number 2, the sign of the middle part is A, side A, equals to the product of the cosines of the two opposite parts. Okay, so cosine of the complement of A, and then cosine, you can use dot. So cosine of the complement of side C. That's it. Okay, next. So let us have the final formula. In the final formula, again, we need to remove the CO. So in removing the CO, so on the left side, we have sine of side A, so we can just copy it. It doesn't have the CO. On the right side, we have cosine of the complement of A, so we have CO here. So let us replace cosine by sine. Sine of the part, that is angle A. Same with complement of C. So remove co. You're gonna replace cosine with sine 2. So sine of side C. That's it. Then in the derived formula, so what we need is the formula for side C. So look at this. So there's no cotangent here. So therefore, we're not gonna use any 1 over tangent. Same as, well, unlike with what we did a while ago. So no need to do it here because we do not have here cotangent. Okay? So automatically you can proceed with derivation. So what we need is side C. This is what we need. So we need to write it on one side alone. So it means that, so let us just write it. So sine A equals to sine of angle A, sine of side C. So what we need is side C only. So we need to move sine angle A. Okay. So we can divide both sides by sine of angle A. So that it can be cancelled here. Okay. So in that case, so we do have, let me just clear this portion. So it means we have sine of side A over sine of angle A equals to sine of side C. This one, we can also write it this way. So you just write the left side on the right side on the left. So we do have sine of side C equals to sine of side A over sine of angle A. Okay. And again, what we need is side C. So we can move sine to the other side by using inverse. So we do have side C equals to arc sine. So you just copy the right side. Sine of side A over sine of angle A. Then you can already what? Actually, this is already considered to be the derived formula. Now, after that, you can already substitute. So, arc sine of sine, our side A is 35 degrees, 20 minutes. Then our angle A is 44 degrees and then 10 minutes. That's it. Then you can already input it in your calcu. So inputting in your calcu. So again, your calcu should be in degree mode. So that is arc sine of 35 degrees, 20 minutes. Sine of 44 degrees, 10 minutes. Then close. So the answer in the calcu is 56.10 degrees. So in degree, minute, and second, so you press the DMS. So that is 50. I'll just write it here. So C equals to 56 degrees, 6 minutes, and 12. So that is 12.22. So that is only 12 seconds. Okay. So this is already the measure of side C. So side C is 56 degrees, 6 minutes, and 12 seconds. Okay. Next, you can already solve for angle B. Angle B. So let us remove the writings here. Okay, we have angle B. So angle B in the circle is here. So again, in determining which rule to use for the neighbors, so you have to determine which is the middle part. So as what you can see in the circle, side A and angle B are beside each other and they are opposite angle A. Therefore, angle A is the middle. And then the two parts, side A and angle B, are opposite. They are opposite angle A. Opposite parts of the right spherical triangle. Then what we're gonna use here is the Napier's rule number 2. And in Napier's rule number 2, so it is said that the sine of the middle part, our middle is the complement of angle A, equals to, so we have opposite, so we're gonna use cosine of side A times cosine of the complement of angle B. Okay, then you check your equation from the circle. Sine of the middle times cosine of the two opposite parts. Cosine of side A, cosine of the complement of B. Next, for the final formula, so we need to remove the CO using the cofunctions. Okay, so sine of the complement of angle A, remove the CO. So sine will be replaced by cosine. So cosine of the part angle A equals to copy cosine of side A. Cosine of the complement of B. So removing complement, cosine will be written as sine of angle B. Okay. So use cofunctions. Again, the sine here was replaced by cosine because it has the CO. And then the cosine here was replaced by sine because it has the CO. Next, derived formula. So the derived formula that we need is for angle B. So same as what we did in the previous, in the previous unknown. So we can divide both sides. So rewriting, so cosine of angle A equals to the cosine of side A times sine of angle B. So since what we need is angle B, okay, we can divide both sides by, so the cosine of side A because we need to move it. And then after that, we can already cancel. Okay, so what we have is the cosine of angle A over the cosine of side A equals to sine of angle B. So this one, we can write it also this way. So sine of angle B equals to cosine of angle A over cosine of side A. Okay, then what we need again is angle B. So it means that the sine can be moved to the other side by applying inverse trigonometric. So angle B equals to, sine will become arc sine or inverse of sine, and then copy the right side, cosine of angle A over cosine of side A. Class, you cannot cancel cosine of angle A and then cosine of side A because these two are different. One is angle, the other one is side. Okay, so this is our derived formula. So after coming up with a derived formula for the unknown, you can already substitute. So B equals to arc sine cosine. Angle A is 44 degrees and 10 minutes. And then cosine side A, that is 35 degrees and 20 minutes. Then input it in your calcu. So input it in your calcu. So it should be in degree mode again. So arc sine of cosine 44 degrees and 10 minutes divided by cosine of 35 degrees and 20 minutes. Then close parenthesis. The answer in the calcu is 61.56 degrees. So it should be in the MS. So it is 61 degrees. So 61 degrees, 33 minutes, and 19.39. So 19.39 seconds. So that is 19 seconds. Okay. So this is the answer on B. Okay. So angle B measures 61 degrees, 33 minutes, and 19 seconds. So that's it for the right spherical triangle.